Hello, my name is Justin Timken, and today I'll be presenting my capstone project. The focus of the project was to study backdoor attacks on deep learning models, and we were provided like a sample code with the PyTorch, and I didn't use all of it. I'm assuming we could use some of it, but I did use the parts to get the binary files, just because I figured these were already somewhat poisoned for the model to show the example. Throughout the course, I've been using the KRS model, so I tried to like implement it, but following the PyTorch example. Later on, you'll see it's not exactly one-to-one, but I got it pretty close eventually. While this is loading, I can talk about some stuff I studied while we were doing it. So I was trying to find like different resources on backdoor attacks on like deep learning models, and I came across this article. I thought this part was really interesting. He talks about how they use noise to like identify where a model has like been poisoned or attacked. And I thought this was really interesting because I've studied like differential privacy for another class, but we also studied in this class, and I know like they use noise to kind of make sure data is safe and like where they have sensitive information like hospitals or something, right? So I thought this was really interesting. I kind of wanted to try to implement it, but didn't really have enough time. Okay, so this is loaded. I also used this from the class, but this is it, just to help like get the data right. So here we can see this is where I defined the model. I had to change this mostly, it was a little difficult to find just because I think in the class one there's like a 1 right here, and then that's how it's defined. But for the Keras model, the 1 is assumed, so you don't even need to do that. I think I did change the input shape too, and I deleted some other stuff from the model that I didn't need. So here, this was the most difficult part, just because I know the PyTorch, they can use it, but for some reason this was not working. I couldn't really figure it out, but it still works without it, but probably not as well. So here we get the training data and the test data, and we apply the malware data set to it to hopefully poison it, right? And then we append it, and then we try to like reshape it and normalize it for the Keras model to run, because without this it doesn't run at all. And then this was also like kind of like a breaking point for me, because when I first trained the model, right, it didn't show the sections of the epoch. It just showed it, and it looked like it was trained normally. So the whole time I was thinking, maybe I'm not loading the data right. So this is when I was like, okay, I think I need to figure out how to take logs for it, right? And is it this one? Yeah, so I found this to keep the logs of the epochs while they're doing it, and here it kind of tells you how to create the function. And then I try to do something similar. I think the class one was divided by 200 so that it showed like 3 sections. This one I just did 10 because my epochs are loading I think it's 44 at a time. Yeah. So this will break it into sections so that you can observe the triggers when like the accuracy like dip when the triggers are activated, right? So I try to maintain the same as the class one, right? Oh yeah, this one I had a big problem with overfitting also when I just try to run it like normally. So I think this like makes it linear, which is I think in the PyTorch one it was just defined as linear. And then the train test split is also supposed to help with overfitting, which I found this call right here. Except I did have it at 33, which I then realized I was splitting the training data by 33%. And it seemed like a little bit too much. I think I also use the atom, and I think that's it. Alright, so let's see. Yeah, I thought this was a really interesting project. I don't know how well I implemented it, because I know in the other notebook the staggers are so much more. Like it will jump from like 75 to 100. I was trying to imitate it, but like you can see, like without the sections, it looks like it's just training normally. And to be honest, I'm not sure if see, this one it slightly staggers, but it's not like as significant as the class notebook. So the data could be inputted wrong, but I think it is working. I mean, you can see it consistently goes down through the end. So I'm assuming, but again, it's hard to tell. When I was looking into like the backdoor attacks, a lot of people use images just because it's easier to visualize with it. But with this, it was so hard to tell, and I'm hoping this is close to being right. So then also prepare the testing data at the end, similar to the class notebook, and then we want to test the accuracy, which should fall in line. Yeah, it's pretty close to this one. Pretty much identical. Oh yeah, one thing I'll note is when I was first running it, the value loss was actually increasing throughout, which was like obviously a big sign that it's overfitting, which the train test split helped a lot. And then I want to talk about this other. So this, I thought I actually misunderstood this when I first read it. So I kind of just scanned through this. I thought that this was training a model, but this is not training a model. They're saving a model that they've already trained. And then where is it? Yeah, here. And then this is actually the backdoor attack for this one. It actually adds a layer to the network. So this will only detect if a layer has been added to the network through a backdoor attack. It's not finding if the model has been poisoned or it can't make correct predictions based on poison data. So when I was running this, if it will run, yeah. So it kept telling me no issues were found. So I was thinking I did something wrong this whole time, and I kept going back and trying to like do different approaches with the data, but everything like I tried to find like a Keras call that was similar to this. There's nothing like so simple as just calling this. But when I finally went back and read this article, I realized that this is just identifying that hey, an extra layer has been added through malware. It's not detecting the poison data. Which hypothetically, if I did use the poison data and it's making incorrect predictions based on the triggers, right? I think this makes it a little scary that this could not even identify that the model has been poisoned and that it's making wrong predictions. I think this is where like you would need to use this method. You would need to kind of add noise to it and try to help you identify where like the poison data is located and what it's doing to the network. I think that's it. Yeah, I linked these, and I linked the class notebook. I think it was a fun project. I really wish I could have tried to do this, even if it would have been very difficult since they also use images to kind of show it. But yeah, thank you for listening, and thank you for the class.